Hi, today I'm going to be giving you a demo of the DivvyCloud platform. DivvyCloud is completely focused on giving your company better visibility, security, and compliance into your public cloud infrastructure. Now, the first thing to note about DivvyCloud is how this is actually deployed, because it's a little bit unique in this space. And what I mean by that is that while we host for a handful of our customers, the majority opt to deploy this as more of a virtual appliance. And what we mean by that is that this is a containerized application. And so for proof of concept, people normally deploy a single instance, pull down all the DivvyCloud containers, and everything lives there. And then in production, we usually break that out into something a little bit more scalable and resilient. So on the Amazon side, we do either like a Docker on EC2 or a Fargate or EKS or something like that, with a MySQL backend most often on RDS. And we do it this way for really three big reasons. The first is permissions to your data. DivvyCloud's completely focused at this API plane for these different providers, and we're not getting down into the host or object level, but this data is still very sensitive, and especially for highly regulated companies, not giving this data to anybody else is a pretty big upside. And so when you have instead one DivvyCloud installation for all of your environments, but that installation lives within inside your walls and you're not giving third-party access to anybody, you get more security out of it. Next is permissions for the right side of things too. DivvyCloud's really had a focus from day one on not just being able to tell you about problems, but actually fix them as well. And if we don't want your read permissions, we definitely don't want the write access we would need as well in order to fix problems that pop up. And then the last piece is extensibility. Now, everyone says extensibility and everyone means a little bit different. What we mean by it is not just that we've got an exposed API that we can share with you so that you can automate actions within the tool, but we can actually take it further. Our backend's all Python based and we've got a plugin based architecture, which means that let's say that there was some service or some internal tool that you had that DivvyCloud needed to interact with. We can actually build that integration in and essentially bolt it onto the side of your DivvyCloud installation by dropping in a plugin to extend this beyond just what you get out of the box and the customization that we've also baked in. So with that though, once this is up and running, first thing we need to do is actually hook into these different providers. And you can see here we support AWS, GCP, Azure, and even AliCloud, and we're hooking into all of these agentlessly. So for AWS, it'd be cross-account role, service accounts for Google, app registrations for Azure, so on and so forth. And once we go and we hook into these accounts and we pull in this different data, the first thing we actually want to do is apply badges to these accounts. Now, badges are sort of an administrative capability, but they're very important, especially at scale. Because, again, think of them just as tags at the account level. And by using this kind of one level higher of metadata, what it allows us to do is very easily group accounts together so we can scope where we run checks, where we run actions, how we scope down role-based access. All those different sorts of things are easier to do if we can lump our accounts together by owner and environment and compliance requirements and all those sorts of things. Now, the last thing to note is how the data is actually collected. Now, by default, for all of these different environments, we're pulling these different endpoints to collect the data. And on the polling side, we do have the ability to fine tune how often we're pinging these different endpoints. All we've seen is that usually when you're polling, companies will ship with a pre-canned kind of best guess of how often these endpoints should be hit to collect the data from them, but it's never perfect. It's a one size fits all. And so most often what our customers will do is speed up polling from the default in their main region, but then slow down polling in their unused regions so that we're getting fast data where we need it. And for those unused regions, we're not burning a bunch of API calls in places where there shouldn't be a whole lot going on. Now, all of that's on the polling side though. For the Amazon side, what we have is something different called event-driven harvesting. And event-driven harvesting moves from a pull into more of a push type architecture. And so what it does is instead of polling, we use CloudTrail plus CloudWatch events to send us the data when something happens. And using this, event-driven harvesting, also known as EDH, we get more context around what happens in the environment. It's a more efficient way of data collection because we're not asking questions of your environment if there's nothing going on. And the time it takes to collect the data is much, much faster. It's about 60 seconds. So I'll show you that demo, that part a little bit later, but just wanted to throw it out there now. So once we go and this data starts flowing into DivvyCloud, I always say that the most basic but most important thing that we do is just take data from lots of places and put it in one spot. And that one spot's here in this resources page. Now, this is our central inventory, but the way we do this for multi-cloud environments is a little bit unique because as this tool was being built, we looked at the services across these different cloud providers and saw a massive amount of overlap. Everyone has to call something a little bit different, but at the end of the day, compute, database, storage, load balancing, functions, you name it, there's usually a one-to-one comparison. And so we said, okay, well, if that's the case, then instead of EC2 versus VMs, call it an instance. Instead of RDS versus SQL Server versus Cloud SQL, just call them databases. And by doing this, we get two things. First, from an inventory standpoint, I now have all of my relational databases, not just across region and across account, but actually across cloud as well. But secondly, and probably more importantly, is that it's not just the names that we standardize, but actually the properties as well, where it makes sense. And so from that means by the time we're looking at this here, when I say these databases are or are not encrypted or are not public, it means the same thing for each. And what that allows us to do is when we're writing rules, I can write one rule here that says my databases should be encrypted and should not be public, and it's going to work across all of these different providers, and I don't need to maintain separate standards for each one. And so for companies that are multi-cloud today, this is obviously handy because they don't need to create separate standards for each environment. But if you're single cloud today, this still really helps future-proof your environment a lot too. So that if, say, down the road, we end up with a merger acquisition that involves you bringing on another provider, you've already got that groundwork taken care of to give you the visibility you need. So this is all on the inventory side though. The core of what we're doing here is really about defining good versus bad and some sort of configurations for my environment. And so I'll show the pre-canned content in just a sec of those checks that we've got, but we're already here, so I'll show the custom content too. And so if I want to go and I want to create a custom check, what I do is I go to this resources page here and I apply a filter. Now, filters can be binary, is auditing enabled or not, or they can be more fill in the blank. And those are most often where the custom insights come in. Because let's say you needed to run a tagging policy. You've probably got something you want to adhere to, but we can't pre-can that content because everyone does it a little bit different. And so in that case, we apply a filter saying, hey, maybe we're looking for making sure that everything has an environment tag and then also only has my approved values of prod, dev, or sandbox. I can fill that in here and I can apply this filter to get this updated view about how many of my databases are not in compliance with this check. In this case, it's still all of them because none of our databases in our demo environment are tagged very well. But with this too, I can do just one filter, or I can keep on stacking these on if I need to scope it down further. Maybe I wanted to see databases that didn't have my right tagging policy, but also were public and weren't encrypted. Any of those sorts of things, we can stack these filters on until I've got some view here that really tells me whether or not things are compliant with this check I'm trying to build. But assuming I like this check, what I'd do is I'd save this off as an insight here. Insights are just DivvyCloud's names for checks. And when I save it off, this then becomes something that I can come back to and drive alerting off of and reporting and all those sorts of things. So that's the custom checks. What about the pre-built content? So for that, we go to our Insights tab here. And this Insights page is going to show us not just all of the pre-canned content, but also anything that we've created custom. And I can actually see them both here. If I change the source from all to DivvyCloud, I can see that we ship with 408 checks out of the box. And then if you want to see the things that you've created, you change it to custom, we can see we've got 144 in this particular environment. Now the big thing though is that with this library, the catch-all of everything, 552 insights, even 400 insights is too many. There's no way every single one of them is relevant for your environment. And so instead we want to go somewhere more focused. and that places over to these packs. Now, within these packs are just collections of rules. And so the ones that we prepackage are collections of rules as they relate to particular compliance frameworks. But from here, just like you'll inevitably create custom insights, you'll create custom packs as well. And those can either be copies of one of these that have then been tweaked to perfectly be relevant for your environment instead of just pre-canned content, or they can be something completely unique that has nothing to do with compliance, but might just be for best practices or governance or some cost management. Any of those sorts of things can also be done by packs because, again, they're just collections of rules. So let's drill into this 853 plus CIS plus best practices pack. Let's say that this was the perfect pack for me. I've squished together the compliance frameworks I need. I've added in my own checks. I've stripped off the ones I don't care about. This list of rules defines perfect for my environment. The challenge is that from here, this kind of gets us to step 0 because I can log in and I can see all these numbers and colors and things like that. But we want something that scales with your environment and doesn't sign you up for spending all day within the UI. And so from there, there's 2 different directions that we can go. The first is more higher level to our compliance scorecard, which is for reporting. Or next, I'll show you how we can create bots for more notification or break fix. So our compliance scorecard, first what we do is we pick what pack we want to see. We'll keep the theme going with that pack we were just looking at. And then again, most often we'll want to scope this down to a particular set of environments. As opposed to giving me some huge top-level view, I might say, hey, show me just how dev is doing or just how prod is doing. Because I may and probably will have different standards for different environments depending on what's running in them. Now within this though, this is going to show us this high-level view of how things are going. I've got my accounts as rows, and I've got my different checks as the columns here. And as you might imagine, red is bad and green is good. And we can go and click in here to get more graphs and things like that. But in my opinion, where you'll get more out of this is that this is something that we can also export. You can either do a browser download as I just did here, or, and more likely what you would do in a production setting, is we would set this up to do like daily or weekly exports. So we can send these reports to people who might not even want to spend any time in DivvyCloud, but they can still get an update about how things are going and where our compliance is. And so with this, what you get is a view very similar to what we were just looking at, but now formatted for Excel. You got all the different checks here. Our impacted resources tab is our full list of all of the different resources that have issues, what those issues are, and also links to pop back into DivvyCloud if we need to dive in to do more forensics or anything like that. And lastly, something we haven't talked about yet, but we do support exemptions as well. So let's say S3 buckets. They should never be exposed, but sometimes they actually should. Static websites and download pages and things like that. For those sorts of examples, we might want to add exemptions so that we don't have to modify the underlying insight, but we can still ignore findings that we've called good for one reason or another. So that's the reporting side. I mentioned the other pieces is more of the notification or break fix side. And now for that, what we do if we want to do something when things go wrong is I create a bot. And you can do that by clicking on this wrench here, or drilling into the insight, which will have more context about what's going on, and then hitting this wrench here. They go to the same place. But you can think of bots like the then that of an if this then that statement. And now with that, we probably want different things to happen depending on different environments. Especially if we start talking read-write, there's no one size fits all. So I can create multiple bots off of a single insight if or when it makes sense. And so for that, again, we're going to lean on badges to scope this down to the right place. It'll automatically pull in my accounts. And let's say I add a 5th account that also has this badge, it'll automatically inherit this bot. So it helps, again, scaling and kind of cutting down on some of that admin work. Next, I'll go through here. These conditions pre-populate from the insight that I came from, so I'll skip this. And now here we actually define what I want to do. And so we should always start with notification. Someone or some system needs to know about what happened, whether or not we're actually doing something about it from within DivvyCloud as well. And so for that, we've got more productized integrations like Slack and PagerDuty and ServiceNow and Teams. Or we can do more generic targets like email or webhook or syslog or SNS and things like that. And so for either one, I can pick what I want to do and how I want to let someone know. In this case, I'll start with just an email. And the overall way that we format the messages is very similar across these different targets that we've got. But the big thing to note is for the actual body, we use Jinja 2 templating, which, if you're not familiar, it's a Python construct, and it allows you to use dynamic variables in these notifications so that we're not sending vague static messages. The goal is that when you get a notification, you understand what's going on, and we're not just signing you up to log into the system to then get context about what's actually going on and what you might need to do. So we send the email out, we get more context around what's going on, and then from here, if I wanted to log something to Splunk or do something along those lines, add an action here. And if I wanted to do more read-write, same thing, stack these actions on here. And the actions that DivvyCloud provides go from very soft to very aggressive. For something like storage containers, this can be things like assign a tag, turn on logging, turn on encryption, versioning, all the way to more of the aggressive quarantine a bucket, lock it down because this data cannot be exposed for whatever reason. But either way, whether it's read-only or read-write, soft or aggressive remediation, we just keep layering these on here until I've got the combination of events I'm looking for. And then the last thing you do with this bot is define when you want this to run, which is almost always going to be these two guys here. The rest of these are more for edge cases, which are outside of the scope of this video. All right, so that's the demo of the bots, and that's really the other big piece of what DivvyCloud does. We define things as good or bad, and then we either go higher level reporting or lower level notification or break fix. But I want to show you real quick how this actually looks in practice with these two bots here. One is looking for a exposed bucket, and if we find it, it's going to send me a notification and quarantine it. The other is looking for unattached volumes, and then we're going to assign an owner tag if we see it and also clean it up. So we'll pop up those two services here. So first I'm going to go to my bucket, permissions, ACLs, and make this guy wide open. I'll save it off. This is public. And now also, actually let me pull up Slack here at the same time. So next we're going to keep an eye on the Slack window here. I'm going to go to volumes, and I'm going to create a small contextless orphaned volume. So what happens here is that right now this is only going to take a couple seconds for these bots to find the issue and fix them, because this account is set up using that event-driven harvesting we looked at earlier. So when I made these changes, the event gets written to CloudTrail, which then forwards off to CloudWatch Events. Now, as soon as it gets sent to CloudWatch Events, DivvyCloud picks it up, and the event is evaluated as soon as it comes into the system. So whenever you're talking about how long it takes for DivvyCloud to tell you something, the only question is how long did it take to get in, whether we're polling or using this push. So the data comes in, both these checks were evaluated. It was found that there was an exposed bucket and this orphaned untagged resource. And so we got these two notifications. First said that we found this orphaned volume. First, it's been tagged with an owner, and second, it's been scheduled for deletion. The scheduled for deletion, in this case, is just to help clean up this demo environment, but our customers frequently will use it to set like egg timers on their different environments, so that maybe for their sandboxes, the resources can only be available for 2 or 3 weeks or something like that, so we don't end up with a bunch of abandoned content in old resources. In old accounts. And then this block here came from that Jinja 2 formatting. This is just a dump of what we see, but we can also curate it more if we want. And same thing, we said, hey, we found this exposed bucket. Here's the context about it. and it's been quarantined. So if I come over here now, let's go take a look at our bucket first. It was public. I'll refresh. And now it's not. And we've got no ACL set. And same thing for this volume. No tags. Refresh. And now we've got an owner tag. And this is a really important piece because where we got this was actually from the ARN of the person who did the event that caused this misconfiguration. This is one of those capabilities that comes out of event-driven harvesting, but is a really important component because, in my opinion, there's a lot of upside for this bot action with not a lot of downside. If we start talking about killing instances that aren't tagged right and quarantining buckets, there's a lot of upside, but also there's a lot of process that needs to be put in place and the organization needs to be bought in. Something like assigning an owner tag doesn't need as much buy-in. People are going to get a whole lot less upset about just applying an owner tag than they are if you're killing off their instances. And also, it's a very quick and easy way to not only increase visibility on what's going on in our environments, but help with cost management and help educate users or roles when they when they might do something that's not in compliance, because we know who to go talk to tell them, hey, don't do this in the future. So those are the two big bot things. And that rounds out the kind of the core of the demo of what I'd call historical DivvyCloud, which is how do we find problems, define good or bad, and do something about it. Now, the last piece, though, is what about solving problems before they exist? And so for that, we end up in our infrastructure as code module. So within our infrastructure as code module, it's a little bit of a departure from kind of that core DivvyCloud we were just talking about, because everything we talked about up to this point only solves problems that exist today. If there's no misconfigured buckets in your environment, then there's nothing for us to tell you and nothing for us to remediate. And I'd argue that's the more important place to be, because that's where those misconfigurations actually live. But what we've seen is that companies want to start solving these problems sooner. And if we can prevent problems from ending up in our environment in the first place, not only does it save time on deploying bad code and then going back and fixing it, but we're obviously increasing overall security as well. So within this module, today it works for Terraform only, and then we'll be adding support for things like CloudFormation and ARM templates down the road as well. But what it does is we take a Terraform plan and we send it up to the DivvyCloud API. And when we send it up to that API, we say, what check do we want to run this against, whether it's that same 853 pack or PCI or anything else. And we get that plan and we'll build out a model of how that template would look if it was deployed. And then we'll evaluate that model against the same exact checks that we're running on live environments. We're not maintaining separate standards for templates versus existing environments. And once we go and we build that model, we run these checks, you then get a response. And the response is going to have two main things. First is a status code. It's going to say, okay, well, was it a fail, warn, or a pass as far as the template goes? And second is why, and it'll add some extra context I'll show you in a second. But the goal with this is that when we built this checkout, we say, okay, well, what do I want to actually fail these builds? Because the goal is that we tie this in with the deployment pipeline, and if the template's secure, the build proceeds, and if it fails, we stop the build and say, hey, you should not deploy this. It's not going to be secure, and here's why. And so using this configuration, we can actually define what are those things that are or are not okay. We can say, okay, well, exposed buckets, that's a no-go. But maybe, if this is like a dev environment, if tagging isn't perfect, it's something we want to warn someone about, but maybe we won't fail the build. We'll just say, hey, you're going to need to get this right for production. So we set that up, and then when we run the script, we get a different status code depending on how that's built out, as well as a response. So let me show you how this actually looks over on the a Jenkins side too. So I'll go over to a test scan, look at my latest build, and what I get here is these two responses, again, in addition to the status code. First, I get a big pile of JSON, which is going to say, hey, pass or failed, and by the way, here's why. This is really for if you've got other existing systems that you want this tool to integrate with. JSON's very easy to manage and manipulate, and so you can take this output here. Or if we're doing this just within that kind of console we were looking at before, and we just want a report so I can show my developers, hey, here's how this went, and by the way, if it failed, here's why. You get this report here, which will show you for all these different checks, what failed, what's the name of the resource that would have been created that's out of compliance, why do I care about this, and all these sorts of things. And so with this, again, the goal is to move beyond just looking at live environments and essentially shift left to identify misconfigurations before they're deployed and take the security that DivvyCloud provides you for your existing environments and take those to templates as well. So with that, that covers the high-level demo of what we do in DivvyCloud. Thank you for your time, and as usual, please reach out to us if you'd like a deeper dive on any of these things or have any other questions. Have a great day.